So we're going to look at shortest path problems, and we're going to be investigating two different ways to solve these. One is using the spanning tree, and another one is using Dijkstra's algorithm. So what we're going to look at is a situation where we've told you where we want you to start and where we want you to finish. You have a start and an end node, and you need to just find the shortest path between them. So it's kind of like saying, I've got to get from school to the airport. What's the quickest way for me to get there in town? Or maybe I have to go pick up a friend in New Brighton and then pick up another friend in Hornby. And what's the quickest way to get between their two houses? You know, which suburbs would you drive through? So that would be when you would be using these. And what I want you to think about doing is it's kind of like a trial and error, but not really. You're keeping track of where you're going the whole time. And you're just looking to see and eliminate options as you go for what is actually shortest possible. So one way that we do this is we show up our addition as we go along. So if you think about looking at this example of home, I might use the one that they've drawn over here because they've put in some of that information. Oh, we'll just do it by scratch. So I'm starting at home in this situation and I'm trying to get to the airport. And these are all the different ways that I can go. So lots of different roads between me and the airport. Different intersections and what's the quickest distance for me. So what I do as I go along is anytime I get to a node, I'm going to write down where I came from and how far I've traveled total. So at this first space, the only place I've come from is H, and I've traveled a total distance of 25 kilometers. So I don't have any comparisons there, but now what I'm going to do is go on to the next ones. So if I go from B to C, my distance becomes 25 plus 10 becomes 35. So I would say B 35 because I've come from node B and I'm now at a total distance from the start of 35 kilometers. And I'll make a comparison for what my other option from B would have been. So if I go from B over to D, I'm traveling an additional 18 kilometers. And 18 plus 25 is going to be 43. So I'm coming from B and I'm at 43. Now, I'm not maybe close enough yet to eliminate one of these, but what we're going to do the whole way along is kind of compare. So at the moment, the more promising path that I've got is actually C, because so far at C I've only traveled 35 kilometers. So let's see where I can go from there. At C, I would go over to E, and I would now have traveled a distance of 45 kilometers. So C at 45 kilometers. And I can see now that C at 45 is actually further than B at 43. So if I were to come down this way, going up to C is a very kind of obscure route to do because going from H, B, D, I'll only have traveled 43 kilometers. And then to get to the airport, coming from D, 43 plus 7 gets me 50 kilometers total. So I think that's going to be the better one. But just to double check it, I should also try going up to see if that's any faster instead of going down to D. So if I go from C, I might go from E, sorry, I might go up to F. And that's going to get me to 48 kilometers. And 48 plus 8 is going to be too many, so it's going to be much bigger. That would be 56 kilometers, so F at 56 kilometers, and we're not going to use that one because it's much further than D at 50 kilometers. And just to double check, going the other way, if I went up to C at 35 kilometers and then went to F, so C to F is going to be 55 kilometers. That's even further than the E. So basically what I've done is I've eliminated my options, and I can see that the quickest path for me to do is this one here. So as you get into these, it's important to try to show your working and try and show your thought process, especially on the assessments. So you'll end up writing some information, which is similar to what they've written out here as an example for you. And also in the notes that I've given you guys, there's another example of kind of the thought process here, so you can look at how to write that. You don't necessarily have to do that in your workbook as you learn to use the method, but thinking about it, what you want to try to communicate, maybe one way to think about it, is just anything that you're thinking as you go through this diagram, try to put into words. So first I tried going from H to B at 25. The next thing I checked out was from B to D, that was 43, and from B to C, that was 35, so I thought maybe C was better, but it looks like you have to go further in the end, so kind of just putting your thought process down the whole way through. So I'll take a look at another example, because it might take a few just so that you see exactly what's going on with them. And then I'll let you get into that. I'll also show you in another video just the minimum spanning. Oh, I might just show you that now, actually. So same problem here, home to the airport. Possibility of using a minimum spanning tree. So the tree diagrams that you may have looked at in the traveling salesman problems. Again, if you want to, you can just write out all the possibilities for yourself and add them up to see which is going to be your shortest path. So for the shortest path method, one, you can be using dijkstras, which is kind of thinking as you go and eliminating as you go. And the other possibility would be to use a minimum spanning tree, which will just give you everything possible. And from there, you'll see exactly what the shortest one is. And for the minimum spanning tree, it's not like the other ones that we did. It's not every single possible way through the network. It is just every single possible way from where you want to start to where you want to finish. So in this case, airport and home.